This lesson will focus on parameters for binomial distributions. Parameters are the mean, the variance, and standard deviation. In this section, we consider important characteristics of a binomial distribution, including center, variation, and distribution. That is, given a particular binomial probability distribution, we can find its mean, variance, and standard deviation. The mean is mu equals n times p, where n is the number of fixed trials and p is the probability of a success in one of the n trials. Variance is equal to the square of the standard deviation, sigma, and the standard deviation, sigma, is equal to the square root of n times p times q. It's especially important to interpret results. The range rule of thumb suggests that values are unusual if they lie outside of these limits. The maximum usual value is equal to the mean plus 2 standard deviations, and the minimum usual value is equal to the mean minus 2 standard deviations. McDonald's has a 95% recognition rate. A special focus group consists of 12 randomly selected adults. For such a group, find the mean and standard deviation. So the mean is equal to n times p. So n is the total in our sample, so we had 12 selected adults. So 12 times the probability of a success. Probability of success is 95%. So 12 times 0.95 is 11.4. The standard deviation, sigma, is equal to the square root of n times p times q. That's the square root of 12 times 0.95 times 0.05. So remember that if you know p, you subtract it from 1 to find q. When we type this in the calculator, it probably is better to type it like this using the multiplication symbol instead of those parentheses. So type it in like that, and then you'll get your standard deviation. Use the range rule of thumb to find the minimum and maximum usual number of people who would recognize McDonald's. So the maximum usual number is equal to the mean plus 2 standard deviations. So my mean was 11.4, my standard deviation was 0.8. So 11.4 plus 2 times 0.8 is equal to 13. So this is my upper limit of the usual number of people in that group that would recognize McDonald's. And then the lower usual value is the mean minus 2 standard deviations. So the mean minus 2 standard deviations gives me 9.8. So if a particular group of 12 people had all 12 people, notice that I came up with more than 12 for my usual. So this is just telling us that you could have all 12 people recognize it, and that would not be unusual. Use the given values of n and p to find the mean, mu, and the standard deviation, sigma. Also, use the range rule of thumb to find the minimum usual value, mu minus 2 standard deviations, and the maximum usual value, mu plus 2 standard deviations. So for this example, n is 60 and p is 0.25. The mean is mu equals n times p. So 60 times 0.25 is 15. The standard deviation, sigma, is equal to the square root of n times p times q. So that would be the square root of 60 times 0.25 times 0.75. So if p is 0.25, q is 1 minus 0.25, which is 0.75. So that gives me the standard deviation of 3.354. The minimum usual value is the mean minus 2 standard deviations. So 15 minus 2 times 3.354 is 8.292. The maximum usual value is the mean plus 2 standard deviations. So 15 plus 2 times the standard deviation is 21.708. Several economics students are unprepared for a multiple choice quiz with 25 questions, and all of their answers are guesses. Each question has 5 possible answers, and only one of them is correct. So we want to find the mean and standard deviation for the number of correct answers for such students. So what's the average number of correct guesses? So the mean is mu equals n times p. So n is 25 total questions, and p is the probability of success. So the probability of guessing correctly, since there's 5 answers, is 1 out of 5. So 25 times 1 out of 5 is 5. So we would expect on average that you would guess 5 correct. Standard deviation is sigma equals the square root of n times p times q. So that's the square root of 25 times 0.2. 0.2 is 1 divided by 5. And then q is equal to 1 minus 0.2. So we get 0.8 or 4/5. So standard deviation is 2. So is it unusual for the student to pass by guessing and getting at least 15 correct answers? Well, let's focus on what would the range of usual values be. So the minimum usual value would be the mean minus 2 standard deviations. 5 minus 2 times standard deviation 2 is 1. So we would expect 1 question correct would be the minimum usual correct guessing. Maximum usual value is the mean plus 2 standard deviations, or 5 plus 2 times 2 is 9. So the maximum usual value of questions to guess correctly would be 9. So it would be unusual for someone to pass by getting 15 correct answers, since 15 is more than 2 standard deviations from the mean. Mars Incorporated claims that 24% of its M&M plain candies are blue. A sample of 100 M&Ms is randomly selected. Let's find the mean and standard deviation for the numbers of blue M&Ms in such groups of 100. So the mean is n times p. So we have 100 M&Ms. Probability of successfully getting blue is 24%, so p is 0.24. So the mean is 24 blue M&Ms on average. Standard deviation is sigma equals the square root of n times p times q. So we have the square root of 100 times 0.24 times 0.76. So the q comes from taking the p, probability of success is 0.24. So q is 1 minus 0.24, which gives us 0.76. So there's a standard deviation of 4.3. Now in the back of the book, there's a random sample of 100 M&Ms, and in that sample they found 27 that were blue. So we want to know if that's unusual. So let's focus on the maximum and minimum usual values, which are always 2 standard deviations from the mean. So the maximum usual value is 24 plus 2 times the standard deviation of 4.3, or 32.6 would be the maximum usual number of blue M&Ms in a sample of 100. The minimum usual value would be 24 minus 2 standard deviations. 24 minus 2 times 4.3 is 15.4 M&Ms. So in a sample of 100 M&Ms, we would expect to find anywhere from 15.4 to 32.6 blue ones. So 27 blue M&Ms falls within this range of usual values, and so it's not unusual. So the rate of 24% is not incorrect.